All right, let's go. My name is Rasmus. My email address is there. Don't bother. This presentation is online. The presentation system I use can generate PDFs directly from these XML-based slides that I'm using. So that's the PHP-generated PDF file that you can go home and download and print out. So I'm eating my own dog food here, using PHP to talk about PHP. I'm going to talk a little bit about sort of the early days of PHP, because people tend to like to hear about that. And I was around back then, so I can talk about it. But I'll focus more on some of the work I've been doing lately for Yahoo, performance and optimization issues, and some of the things that people fall into that tends to be very bad for performance. But going back to about 1994 or so, or 1993, 94, I must have written 1,000 programs that look something like this. I don't really expect you to read it and understand it, but this is a CGI bin program written in C that does very little. It puts up a form with a name and an age field and an input submit button. You can pick it out of the put as calls here. Then there's a bunch of playing around with pointers to actually figure out what was the posted data and pick out this name and the age that someone inputted. And the only thing it does with this data is print it back out. So hi, your name, you're this many years old. This is a lot of code to do something that is trivial. We're solving a trivial web problem with 35 lines of code that's very easy to get wrong. And then if you need to change the background color of this form, you have to go back in, fiddle around with the put as statements there, recompile, redeploy. It just wasn't a viable way to solve the web problem. Everyone and their cousin then moved to Perl in 1994, 1995 or so, using Lichtenstein's CGI Perl module. And this is a very structured approach to solve the same problem. This also puts up a name and an age field and a submit button. You can see it prints out the header, start HTML, an H1 tag, start the form, the name, the age fields, P tags in between, submit button, end the form. If there are some parameters, echo out the name and the age parameters. Very structured, very nice. Programmers tend to like it. The problem is that to really solve the web problem, you can't have your programmer sitting around fiddling around with forms and how the forms look and how the graphics look. In any sort of medium-sized project, you're going to have to split the responsibilities. You're going to have a back-end person and a front-end person. And the front-end person doesn't necessarily understand Perl. Generally, they'll sit around with FrontPage or Dreamweaver or one of these HTML authoring tools, and they create the look and feel of the site and do all the artwork and then pull stuff together. If you split this into FrontPage and try to click on, say, change background color, it's not going to work. FrontPage doesn't speak Perl. Right? Does anybody here know how to change the background color of this form? Okay, so we have a room full of web geeks that have no idea. There you go, that proves my point. Basically, it's an argument to the start HTML function call there, where you can put in the background color of the form. But I mean, HTML people are used to looking for the body tag and putting background color, or using CSS or another method to change the form, or they'll just click in their HTML authoring tool. So this didn't really work for me. Lots of people use this, but it was no good. I needed something else. I needed something that looked more like HTML. The HTML had to look like HTML. And when I needed something dynamic, I wanted to put a special tag in at that point. So this, although it doesn't look as structured or as nice as the Perl implementation, you can put this into FrontPage or Dreamweaver, and you can play around with the form. Make it look nice or change the background color. So somebody else can do that front-end work. And that was how the initial version of PHP was. That there wasn't actually any logic at all. There was no if tags. There was nothing. There were only these macro tags that went into, basically called into a C library where I had written all the business logic. So I gave a cheat sheet to the front-end people and said, look, here are the 20 or 30 extra tags that we have to solve our web problem internally. Whenever there was a new thing that the web developer had to talk to some other back-end system, I would sit down and write code in C and then expose that business logic via a tag to the front-end people. So PHP started very much as a complete templating system. There was no business logic. You could not write a PHP application as such. A PHP application was a front-end template, back-end business logic. All back-end business logic was written in C. The front end stuff was all HTML with a couple of special tags tossed in. That didn't last too long because, first of all, there were multiple browsers that came out back then, so you had to have different HTML based on which browser people were using. And it was also nice that you could bring some of the presentation layer, or you can apply some of the same things that you can do in a real structured language to the presentation layer, so that you can, say, include files and put all your layout in a separate file, and each template could just be the content that then included the layout. So if you wanted to change the background color of all 1,000 pages on your website, you only had to change it in one place. And also being able to tell, hey, for this browser, send this particular HTML. For that browser, send this HTML. These are presentation level logical decisions. So the people working on the presentation level back then asked me, hey, can we have an if tag? Can I say, if Netscape, do this, if IE, do that? And I looked at my stuff. I had a state machine. I had 2 states back then. You were either in HTML or you were inside a tag. And the tags were just sort of picking out the actual string of the tag and then calling into a backend C library. There was nothing else. There were 2 states. So when they asked me for an if tag, that meant all kinds of other things had to be added. You have to have some way of calling something that checks the browser, storing it somewhere, and then doing a condition on that. So I looked at my stuff and, well, I could probably do it. So I made a way for a tag to return something in a variable. And I made an if tag, so you can then check that variable. And those were the 2 extra things. Added about 4 states to my little state machine. So I was up to 6 or 8 states. I forget how many. And that lasted maybe 3 hours. And someone said, well, there's an if tag. Why not an else tag? And I looked at my state machine. OK, it's really only one more state. Fine. But as soon as you start doing that, it's a slippery slope. When do you stop? Right? Someone else said, well, I keep calling the same thing over and over again. I keep calling the same tag. Couldn't I put that inside some kind of loop? I mean, a while loop is very similar to an if condition, basically. You check a thing and then you repeat it. I looked at my state machine. OK, so we'll have a while loop. And then include came in, and someone said, I want to define my own tags. I want to be able to define start form. That then should spit out a whole bunch of HTML that I always put at the beginning of my form. So then functions came in. Someone wanted to call the function from within the function, which I couldn't understand. Why in the world anybody in a web application needed recursion? I mean, what are they doing? Fractals? I didn't understand why they wanted it. But I looked at my state machine, and I just had to go back to the same state. Easy, no problem. Implemented it. I didn't have any static variables. So there's no way to end your recursion. So once you recursed, you were stuck. You had to kill the process to get out of the recursion. They didn't like that. But I said, well, you only asked for recursion. You didn't ask for a way to exit the recursion. Anyway, that was sort of how the early days of PHP went. I had no intention of writing anything that resembled a scripting language in any way whatsoever, which is quite obvious if you looked at some of the early code. That was not what I wanted to do. The very first version of PHP was all sort of handwritten. There was a state machine, and I wrote my own lexer, and it was all handwritten code, sort of in my head trying to figure out character by character how to parse an HTML file with some embedded logic like this in it. And if you sit down, and try to figure that out yourself, it's a pretty damn tough problem. Wrong keyboard. It's pretty hard to actually parse something character by character and keep track of it all and execute it right. And it took me a while before I found Yak and Lex. I didn't actually understand Lex very well, so I skipped that. But I used Yak for version 2 of PHP, which helped a lot. Yak is a way to define the language. You just define the grammar of the language, and it generates basically the state machine that then it checks the syntax and everything and gets order of operations and precedence and all these things. It figures out on its own. All the stuff that I had to sit and hand code for version 1, it sort of took away all that tedium and let me worry more about the features of the language. But anyway, those were the way early days. And my over the years, then I didn't sit down early on to say, OK, I want to write PHP, and everyone's going to use it because it has these characteristics. It's sort of the other way around. I wrote some stuff, people liked it, like, oh, great, whatever. It was from me I wrote it. And I think most open source projects start like that. Someone sits down, has a problem, needs to solve it. Later on, I sort of looked at it and said, well, why does everyone like it? It's kind of weird. I mean, it was kind of a hack. It's not the greatest language in the world. It's kind of ugly. It's kind of inconsistent. But there are millions of people out there using it. I think one of the reasons is that it has a very shallow learning curve. You put up some static HTML, you can add one tag to it, and boof, you have a dynamic web page that works. It's also extremely simple. I mean, hello world in PHP is hello world. You type hello world in a file and run it through PHP and it says hello world. It's the shortest hello world program anywhere. I mean, no other language has a shorter hello world than PHP. And I mean, it makes sense. I mean, why shouldn't a file that just contains hello world spit out hello world? What other thing could the programmer possibly mean by that? Nothing, right? It should spit out hello world. So there is no initial hurdle. People can get started with PHP without knowing anything at all. And they do, all the time. It's all over SourceForge. And also, I wanted to build on what people knew. Whenever I try to come up with what tag or what should a while loop look like, or what should the function call look like, what should arguments look like, it's like, well, the only language I really knew was C. I've done some Pascal and a little bit of COBOL and some other strange stuff. But basically the syntax is C with some Perl tossed in, a little bit of C++, a little bit of Java. We weren't trying to change the world. I mean, I wasn't initially, and then later on, as more people joined the project, I mean, we didn't set out to try to change the world and how people programmed. We just sort of said, well, what makes sense? What might people expect it to do, and try to do that. Also, the documentation is pretty good. There's really no point writing code that isn't documented. It's hard to explain that to people sometimes. Programmers just want to code. But if you write all kinds of code, very complex stuff, no one documents it, you might as well not have written it. The last one on there, sort of my favorite one, that I think PHP teaches the basics without hiding the problem. There are other things like ColdFusion, for example, that has a very pretty front-end GUI that hides the complexity somewhat. You can point and click your way and write a web application with ColdFusion, and it's very cool. The front end is very nice. You can build some very, very nice web applications with ColdFusion. But you can only get up to a certain point. Once you get beyond what the front-end GUI was designed to allow you to do, you're in trouble. Because then you have to get underneath the skirts of this thing, and the scripting language behind ColdFusion is ugly. It is this tag-based thing that doesn't look like any programming language in the world, and you have a huge paradigm shift. You get up to a certain point, then bang, you certainly have to learn all kinds of really complex stuff that's not based on anything you know, and basically most people just get stuck there. They can't go any further. With PHP, there is no big paradigm shift. The tiniest little application running on someone's personal homepage somewhere versus the biggest application, busiest thing in the world at Yahoo, for example, it's all the same thing. They're not that different. Sometimes they should be more different than they are, and I'm working at that at Yahoo, but they're really not that different. And the web problem is simple. You spit out some HTML, it's all ASCII. User types something in, sends some information back, you do something with it and spit back a result. That's all it is. You can break down the biggest problem in the world to just sort of pages, HTML pages, and each one has to do a certain function. If you put them together right, you can build anything you want. So, the way I had initially pictured PHP was as this framework, the way I was using it, building all your business logic in C or C++, and having a nice framework for exposing that application out to the template. And the very first release of PHP, it was framed that way. It was said, look, this is a set of tools based on this framework. I had a tool that would show when the last person logged in or when the last person accessed your web page, how many hits that web page has had. So a very fancy hit counter. I had some logging tools where you get a nice graph and some nice charts of who has accessed your web page. So I had built these tools that went along and illustrated how to use the framework, and that was my initial release. Nobody used my framework. They just said, hey, cool tools. We need a tool that does this as well. And I said, well, this is what the framework is for. Use it to build your tools. Like, well, this looks very complex. Like, no, it isn't. It's easy. Look. And then I would do it for them, send it to them. Look, this took me like 45 minutes. Here you go. I used the framework to build you this tool. And I said, great, thank you. We also need this tool. And I did that, I don't know how many times I wrote these things for other people. to try to illustrate how easy it was to use the framework. And nobody ever used the damn framework. They just wanted sort of the tools, and they liked the HTML side of things. They liked the templating side of things. They liked all the special tags that could do interesting stuff. And I kept saying, well, write your own tags, and they wouldn't do it. And that's sort of when things started to change a little bit for me. Well, wait a second. There aren't enough C and C++ programmers in the world. The web was expanding so fast that we just couldn't keep up. There weren't enough developers. A lot of junior people, a lot of people who knew nothing, that just knew a little bit of HTML, were put in positions where they needed to solve very complex web problems. And they needed a tool. And that's why they sort of they latched onto that part of PHP. And I think that's why that part of PHP really expanded and became a full scripting language, because people needed the power at that level. They didn't want to go up to C and C++. That was not anywhere near what I had thought initially. It's gotten quite successful. About 35.8 million domains were queried last month by Netcraft. 10.5 million domains had PHP on them. It's growing pretty steadily. Someone took a bite out of the chart there in 2001. That was the big .com crash. The actual percentage of domains has gone up almost every month. Every now and then it's been steady, or maybe down a little tiny bit, but it's been pretty steadily going up. Even when the dip in the chart there, the percentage was going up. It was just that a whole bunch of websites disappeared. Poof, they were gone. So the absolute numbers went down, but PHP usage didn't actually go down. Another company checks all the Apache servers out there they can find. Last month they checked 5.8 million servers and found 2.9, basically 3 million servers running PHP. So over 50% of all the Apache servers out there have PHP installed on them. So here's an architecture. I was talking about how I thought people would write their business logic in a strongly typed, structured language, and they didn't. And this is more what people are doing, or at least what I'm suggesting that people do when they write a PHP application. At the top, you have the template, which has your content and the look and feel, all the HTML that makes up your web page, with very little PHP in it, hopefully. A lot of people don't do that. But this is one of the things I'm pushing pretty strongly at Yahoo. We need the very front-end pages to be very light on PHP. If you go look at these pages behind php.net, the website, there's a little view source button. You'll see that the actual pages have very little PHP in them. They'll include some files, they'll call some functions, and maybe loop a little bit, but very little actual business logic is in the front template. You need to separate your presentation layer and your business logic. The fact that PHP lets you mix it doesn't mean that you have to. It means that you can hack up very quick solutions, that's nice, but for real projects, you really should separate it nicely. So at the top, HTML templates. Below that, template helpers. Basically these are functions that have HTML in them that help you out with things. So start form, end form. Whenever you need sort of common bits of HTML spit out and you would rather separate that out into a separate file, you would put that in a different place. Then business logic written in PHP. I generally put that outside the document root somewhere in an include directory. And then finally, you might have to write some custom extensions. At Yahoo now, we're up to, I think, 48 custom extensions written in C, most of them in C++, actually, that do various things. So the business logic all sits either written in PHP or more and more stuff. As the bigger your site, the more traffic you get, the more the business logic you have to push down into C or C++ to get the performance that you need. So this is an architecture that I sort of recommend to people. You can also generate PDFs. I'm not going to go into it very much, but you basically generate it call by call. So start a new PDF file, set various attributes, set infos. You then, whenever you start a new page, you give it the size of the page. You can then specify A4, for example, is 592 by 842. Letter is 612 by 792. Specify the size of the page. If you want to put images in, there are functions to open various types of images. Here I'm opening up a JPEG, PDF open JPEG. Place it somewhere, close it. The one annoying feature of doing PDF stuff is that the origin is bottom left. So 0, 0 is bottom left. If you want to do something in the top left corner, you have to go to 0, 700 and do things there. There are ways to flip the coordinate system. So if you prefer top-down approach, you can flip it as well. So this little script that I wrote, it's kind of long, but it generates an invoice. The invoice looks like that. Right? So the idea here is that you generate basically the template for your PDF, and that you then just call a function with an array full of all the items, and then the items get rendered and put into your invoice. Shopping type websites like these kind of things, because printing out HTML is horrible. It's hard to make HTML look nice when printed. So generating a PDF based on some database calls to get the user's address and records and picking out what's in their shopping cart and then putting all that stuff in the PDF and generating it is very nice. And you can also maybe store their paper size preference in their profile. There's nothing worse than sitting in Europe and getting a US letter formatted PDF. You try to print it and it just doesn't fit. Right? Or if you always have US legal in your printer, for example, you can specify, hey, I always want stuff printed on US legal. And most times, if they're not dynamically generated, you can't specify your paper size for your PDF. You can also do Flash. We can spin logos. It's not on fire, but that's the next version. Version 3 will be logo on fire. But basically, you can use the Ming library to generate Flash. So you start off a new, here I'm creating a shape. I'm putting the image inside a shape. I put that inside a sprite, and then I rotate the sprite. Put the sprite inside the movie, put the movie somewhere on in my page, basically, or in the little window, the Flash window. Set my animation rate, set the dimensions, and output the fact that here comes some Flash. This is the MIME type for Flash, and then call the output method on this object. It's a little bit complex, the API for Ming, I think. It's pretty well documented. If you want to play with it, go to opaque.net/Ming, read the documentation. It's fun. So the spinning logo thing, of course, but you can also do other things where you combine Flash with external sources of information. Here I've used the RSS class in pair that takes an RDF file and gives you all the entries. An RDF file is sort of a news syndication file format that a lot of online news sites will give you, either RSS or RDF. /. If you go to /.org//.rdf, you'll get this XML file that has all the headlines from /. So I've taken that, downloaded it, I'm parsing it. Parsing it is pretty easy. You start a new object, parse it, and then call getItems on it. That will return you an array with all the strings. Then I start off a new Flash animation, do a little bit of fancy Flash, and at the end, what I get is something that looks like that. So I get all the /. Headlines sort of floating out at you. They're also clickable. So if I had a network connection, clicking on any one of these would take me directly to the appropriate /. Story behind it. So you can make some nice banners and things. What you should be really afraid of is that since I obviously work for Yahoo now, Yahoo has a lot of Flash ads. Now these things can get very dynamic. Once the Flash guys at Yahoo figure out the fact that, hey, we can make dynamic Flash. You're going to have Flash ads that are going to connect off and get information and actually sort of customize the Flash ad for you. They haven't quite figured that out yet, but I'm sure they will. And they can do some evil stuff with that. Just wait and see. So all this dynamically generated content, sometimes if you had a site with a bunch of images and you dynamically generate them every time, it's going to be somewhat slow. Buttons. The text isn't going to change very often. There's no real point dynamically generating a button if you don't cache it. So here's a cool little way to cache these dynamically generated images. I configure my Apache server to have a 404 error document. So when a request comes in for a certain image in my images directory, and it's not there, it's not sitting in my images directory, I'm going to get a 404 error. That's going to get redirected to my generate script. So I have a generate.php. In generate.php, I have a look at which image they asked for. I split it up with a regex here. So I split it up into components separated by underscores. So you can have like the type of the image that was requested, maybe the text and the color and the extension. So using that information, I can then generate an image. So if they ask for a JPEG, fine, I'll generate a JPEG. If they ask for a PNG, I'll generate a PNG. GIF, I'm also generating a PNG in this case. I don't do GIF. And then the type of image, either a solid square or a button is all I've done in this case. The button was the example from before with the nice outline text, starting with this wooden background. And then I spit it out. But the big trick here is that I save it. So I spit out my image PNG. $im there, but just above that, I also save it to the file that they requested it in. So they asked me for button underscore test underscore 0000.png. Apache checks my images directory. It's not there. Redirects to my generate script. My generate script generates the image, saves it to that location, button underscore test 000png. The next request for that button image, Apache is going to see it on disk and it's going to serve it out statically, right? So in order to refresh my cache, I just have to delete all my files and they will get regenerated at that point. And it's very nice to generate buttons this way because then as you're writing a site and if you want graphical buttons, you can just image source and you can just say, okay, this is my button file name. You don't have to drop off into an image editor to actually create the button because you already have a script that generates all the buttons for you. You can just keep coding. You don't need to worry about it. If you want to change your background image, you have to go and delete all your buttons. And this leads us into a pet peeve of mine. Very, very ugly URLs. Previous guy was talking about URLs in magazines. Nobody likes to type them in because they're too damn long and complex. They don't have to be long and complex. People need to understand path info. I wish more people use path info. $path info is this cool thing. It's basically, after Apache has finished figuring out what to do with a URL, anything left over, it sticks into path info. So if we configure our Apache server to say anything /products, this location /products is going to be a PHP script. This is the PHP MIME type. /products is now a PHP script. So this looks like a directory, right? You might think, looking at the URL, this is a directory. Inside directory, there's something called, inside products, there's something called routers. That's because you're thinking of a URL as a remote file name. Don't do that. It's called a URL for a reason. It's a universal resource locator. It locates stuff. It's not a file name. It has nothing to do with the file name, right? In this case, products is the actual script. So you put a text file in your document root, name it products. Not products.php, just products. And put your PHP code in there. Apache is going to execute that script. In that product script, you can then check $path info. $path info is going to be /routers. And you can do stuff with that. Select star from products where description like path info. So pick out of your products catalog, pick out all the things that have something to do with routers. So people can type any URL they want. company.com/product/ whatever they want. And they will get a logical page back that's going to give them something. Just because they don't know the exact URL doesn't mean you shouldn't give them something. And that's my big pet peeve, that I never know where things are on websites. You always have to go to the front page and then you have to click your way and try to find stuff. If more people would say, well, let's just put all our products under /products, for example. Let's just, or if you go to ibm.com/t20/CPU/speed, right? If you put all those keywords in there, why doesn't ibm.com tell me what CPU is in a T20 laptop and what speed it has? Because they didn't put that, it's on there somewhere on their site, but they didn't put their information there. They put it somewhere else. How am I supposed to know where the heck it is? Why can't I just type my 3 keywords and have it pop up? Why can't the website give me the information where I think it is? I think it should. So to do that, to go further than just the /products idea, you can go back to the error document approach that I used with images and say, well, any 404 error, let's put it to a PHP script. Let the PHP script try to figure out if it can do something intelligent with it. You'll notice on php.net, you can go to php.net/ whatever you want, and it'll tell you something. If you actually put a real function name that exists in PHP, it'll give you the manual page for that particular function, which is a very cool feature. And you can do other things with that as well. What I really like is caching this stuff. Just like a cached image, you actually generate the content that you want. So here I've used output buffering. Output buffering start, generate my content, maybe it's a database query, whatever, fetch the contents, write it to where they asked for it. You would put some restrictions in there. You don't want them overwriting stuff they shouldn't be. So you might restrict, put some other checks in there to say, okay, under these directories, allow people to do that. But basically what this does is it puts the information where people think it is. It might write the same information in 40 different places on your drive. Who cares? Disk is cheap. Customers are hard to find. If people think the information should be here on your site, put it there. And let it go there automatically. So what if they have the URL wrong? Yes, you should have put the CPU type before the machine type on ibm.com or something. That's crap, right? They got the right keywords. It's like walking into a store and asking for a product by slightly the wrong name and having the clerk kick you out because you got the name wrong. It makes no sense. Computers are really good at finding stuff. Let it find stuff for you. And who cares if you have the same information in many different places? Yes, you need to add some logic here that goes through and deletes those files when you update your product database, for example, or wherever else that this content comes from. When you change that content, you have to make sure you go through and figure out where it had been written to and then delete it. So it's not quite as simple as I'm making it seem here. But still, the concept is still valid, that why just have one place where you're putting stuff, and why do you think that you are right when you're saying, well, this should go here? It doesn't matter what you think. It matters where the hell people are looking for stuff. Put it where they're looking for it. If someone has a wrong URL somewhere, they put it in the document, Google gets it, you're going to get so many clicks on that particular link, and you're going to get annoyed, and you're going to have to put in special routes or redirect them and stuff. And why bother? Just put it there. Let it create itself there. All right, I'm done with my rant about URLs. Let's talk more about optimization now. That's more interesting anyway. To optimize stuff, you can first look at very basic things in your code. I mean, stupid regular expressions, changing one character to another character. Don't use a regular expression. Use a string replace. Have a look at all your regular expressions. Make sure you need them. There are good direct string manipulation functions that are much quicker in PHP that can do simple things like checking the extension, for example. You can do it with a preg match, but a substring can do it faster. There, the good on the second example there basically says, go through string, start from the back, search backwards, find the first period that you find, and then get me the string from the period onwards. So that basically gets you the extension quicker than you can do it with a regex. Sometimes, if you're passing large data structures around that you need to change, then passing them by reference can sometimes save you some memory. Although, because of the way PHP does copy on write, often there's really no point in passing things around by reference. Persistent database connections, if your database is really slow when you connect, use a persistent connection to it. That means that the connection stays up from one request to the next. That can speed things up. If you're using MySQL, you have large selects. You have large result sets. Have a look at MySQL unbuffered query. That leaves the result set in the MySQL daemon's memory space. And it doesn't block on the query. It only blocks on the actual select on the row. So you send off the query. You can go do something else. And as soon as you try to get the first row out, if that first row has fallen out and is ready to be sent to you, even if the entire query hasn't completed yet, if the first row is available, you'll get the first row. Then on the next fetch, if the second row is available, you'll get it. Also, it'll block until the next one comes out. And sometimes you might have screwed up slightly, and you're actually getting a 10,000 row result set, and you're only going to show the first 50. So looping through, and once you have 50, you're done. You can go on to the next thing. And it'll appear a whole lot faster because you're not going to wait for the entire 10,000 row result set to be selected and found and given to you, which is what happens if you just use MySQL query. And my final point on that, don't over-architect things. If you're sitting there going, oh man, this is getting complex, or how do I do this again? And if you really don't understand your own application, you're off base. You need to take a break, have a beer, rethink this thing. Almost always, the simple, obvious solution is the right solution. And if you have fallen away from the simple, obvious solution, you have to somehow get back to it. I see that a lot. It's sort of a weird, vague thing to tell people that don't over-architect, but I see it all the time. Huge whiteboards filled with boxes and arrows and stuff about how this stuff should work. And you look at it and go, whoa, this is never going to work. And they make it so modular that it's going to solve every problem in the world. And like, focus on your problem, solve the problem, get your problem solved. Yes, think ahead a little bit, but don't try to solve the problems that you might possibly have in 5 years. Other optimization stuff. If you have a MySQL-backed application, check for non-indexed queries. Your slow query log will help you there. So if you start your MySQL daemon with log slow queries and log long format, then you can use MySQL dump slow, which is a command line command that will give you all the slow queries that have happened on your server. If you go through the slow queries, try to figure out where those slow queries came from, that'll give you a massive amount of information of where to start looking at speeding things up. So here I have just some example output from MySQL slow query, or MySQL dump slow, that shows some of the slow queries that have been done on this particular installation. So select star from users is one. I mean, there's no, it's going to do a full table scan. It's going to be somewhat slow. That's one that you might want to restrict. If you have 1 million users in your database, nobody should be doing a select star from users, because you couldn't possibly use all 1 million on a web page anyway. So you have to track down who did that, get rid of it, put a limit clause in there, put a where clause in there, put something in there to speed that up. This isn't really optimization, it's just cool. There's a MySQL UDF. UDF is user-defined functions. Basically, you can write MySQL functions that run inside MySQL in PHP. So you can do stuff like executing PHP functions. The second example is select PHP string ftime. So that's string ftime is a PHP function. The PHP parser has been embedded inside MySQL, and you can now execute PHP inside MySQL. I find that pretty cool. You can also do scary stuff where you actually apply PHP functions to the arguments that you are selecting. Here's one where we're doing a string to upper. We've inserted stuff in lowercase, but we're using PHP. And we're actually putting PHP code into MySQL and then using the code that's sitting in MySQL and applying that to each selected row. That's really nasty. So you can see select code, come as from test code where code name equals capitalized. Capitalized was the code that was inserted that contains string to upper argv1. That is then executed and capitalized. I'm not using this anywhere. I hope nobody is using this for any sort of production stuff yet. But there are some fascinating implications of being able to run very complex code inside MySQL. Written, well, not just written in PHP, in any language. I always, for example, people are always arguing that they want to put their image data itself for a JPEG, for example, inside MySQL, and I never really understood why, because you can't do any sort of intelligent selects on just image data. You can't say select images where image contains a red car, right? Unless you have some other keywords where you have say this image contains a red car, there's nothing in there that will analyze the image and find the red car. You could possibly do that with PHP and its image functions. You could possibly look at pixels and see, okay, here's sort of the shape of a car. They're mostly red. Okay, this image matches. It'd be massively slow, but it'd be cool. So, back to the optimization and speed freak stuff. I tend to always put a squid reverse proxy out in front of my web servers these days. So I never actually have my web server listening to port 80. Which might sound weird, at least not my external port 80. I always have a reverse proxy out in front that takes the initial connection and figures out what to do with it. Then my Apache web server sits in behind that, usually on the loopback, port 80 in this case. So Squid will go through, check, okay, here's a request for a certain page. Do I have it in my cache? If I have it in my cache and it's not expired, serve it up. So that request doesn't even touch my web server. If it's not in the Squid cache, it goes through to my web server. When web server generates the content, I'll put the appropriate cache headers on the content to say, please cache this information for 30 seconds. Give it to Squid. Squid will then serve up any request for that particular URL will get served up from Squid for 30 seconds. Think of a news page where you have new news stories in a database somewhere. To generate that page, you send off a query to select the 5 latest stories from your database. If you just put a 30-second delay on this thing, and you're getting hit 100 times a second, or even just put a 5-second delay, meaning that at worst case, you create a new news story, you put it into the database, it's going to be a 5-second delay between putting it into the database and the first person seeing it. But if you're getting hit 100 times a second, and believe me, 100 times a second is nothing. You should see the traffic at Yahoo. But 100 times a second, and if that, say, took just one SQL query to generate that, which is pretty light, that's still 500 requests that are now no longer going through to your SQL server. So you have gone from 500 requests down to 1 request every 5 seconds. That's a huge load that you just offloaded for a 5-second delay on the actual content. And it makes no sense not to use something like that. A 5-second delay is nothing if you have a very heavily hit server. You will have problems if you need to personalize these pages, obviously. If you have to put the username up top, people have to log in or something. Partial caching is tricky. There's no really good way of doing that with Squid. I have thought about embedding Squid or embedding PHP into Squid. So you get 2 levels of PHP tags. So inside Squid, you would then maybe use the ASP tag style for stuff that should be executed at the cache level. So you generate your main content, but you have a separate tag style that won't get parsed at the main level, but only get parsed up at the cache level. That would enable you to do some personalization at that level. That would be really cool, I think, but I haven't gotten to it yet. Other things you can do with having a Squid cache out front, you can have multiple instances of Apache. If you're doing any kind of virtual domain hosting, this is a very nice way of completely separating them so you don't have the same users, the same user ID, well, different users running code under the same user ID. Here you can have completely separate instances of Apache, just attach it to different ports, but have Squid serve everything up over port 80. Nobody wants their server to sit on port 1234, right? So people have to type domainname.com/1 or :1234. Nobody wants that. But with Squid out front, it can figure out that any request for this particular domain should be gotten from this particular server running off of the loopback port 1234. So that's a nice use for it as well. This is mostly so you can have a look at how you might configure Squid to do this. If you look at the PDF file, I showed the URL at the beginning, download it and have a look at it if you're interested. I'm not going to go through it. Load balancing is also a really cool thing that you can do with Squid. Some easy ways is you can go through and just basically set up round robin in your etc hosts. So if you have 3 web servers, you put a single Squid server out in front. If you want to load balance across the 3 web servers, you can put round robin stuff into your etc hosts. You can also use cache peer, which is sort of a cooler way of doing it. Cache peer was originally created to have sort of a tree of proxy servers, but the protocol used between them is actually just HTTP. And you don't have to use a tree of proxy servers. You can also make the things that the proxy server talks to web servers. So you're sort of tricking it a little bit, but it's kind of cool. So if you were interested in doing load balancing with Squid, instead of the obvious etc hosts that most people will tell you to use, have a look at the cache peer stuff. Do a little bit of searching around and read this stuff. This is a more intelligent way of doing it. And you'll also find a lot of people that will say, well, use some kind of redirector. SquidGuard, which I showed in my last example, can redirect. It's a thing that you can write code in Perl, basically, that every request comes in, it goes out and runs some code to figure out what to do with the request. It tends to be really slow. There are ways to trick it using ACLs and this cache peer stuff, so you can do full load balancing directly with a Squid configuration without any sort of redirectors. I know it's a little bit complex. I'm just sort of mentioning for people who are starting down the Squid route, and just to put a seed in your mind that there are different ways of doing this. Have a look at ACLs if you're doing load balancing with Squid. Or, of course, you can bail and use a hardware load balancing solution, or even the Linux Virtual Server project has some cool stuff on that as well. At Yahoo, we use mostly the Foundry stuff. Big hardware boxes out in front of the Yahoo servers. So I'm getting to a point here soon. So keep the load balancing in mind, and we'll now look at the database side of things. So I'm working up to a full architecture for really, really damn fast serving up of content. So in order to do that, often your database server is a bottleneck. Replication can help you out a lot. And turning on replication in MySQL is trivial. You turn on binary logging. So in your my.conf file, turn on log bin, set a server ID. In the little cluster of MySQL replicated servers, you're going to have a master and some slaves, and each one has to have a unique ID. So I usually call my master server ID 1. You also have to create a user and a password to do the replication. If you're using MySQL before 4.02, do grant file on to whatever your username is, identified by what your password is for the user. If you're using 4.02 or later, instead of using file, put replication slave there, grant replication slave on whatever. On your slave servers, you have to then identify the host that you want to replicate from, the username, the password, perhaps the port, and set a different server ID. I also usually turn on binary logging. You don't have to. Slaves don't need to do the binary logging. The binary log is just basically a log of everything that happens on a particular server, so that you can then replicate. You can sort of replay that log and catch another server back up. I turn it on to my slave, so I can use a slave as a backup master. And there's actually an SQL query you can issue to change the master. I think it's called change master even. I'm not quite sure. what the query is, but you can actually tell all the slaves very quickly, now use this one as a master so that you can do maintenance work on your real master server, for example. Then you can switch it back when you're done. So that's kind of cool. And you might also set various things for, basically we're going to use our slaves as read-only replicas of our information. So you can set a couple of things to make it faster for read-only. You can increase the number of connections it can take. You can, when you start up your server, you can do skip BDB, low priority updates, delay key writes, things like that. And basically what I'm getting at is this kind of architecture. A squid cache out front, some kind of load balancing mechanism, have a web server. On each web server, you also have a local MySQL running. Those are the MySQL slaves. You write your application such that all reads go to the local host MySQL, but all writes, all database writes, are going to the master MySQL server. Most web apps are read-heavy. If you have a write-heavy web app, meaning that you have more writes than reads, this wouldn't work very well. But most web apps really do a lot more reads than writes. And being able to then offload all the reads from the master server and just do it over the Unix domain socket on each web server gives you a massive speed up on a read-heavy application. We do this quite a bit at Yahoo. Not exactly like this. We tend to have our slave servers on separate machines, actually. So we have a farm of slave servers. We have a farm of web servers. We have load balancer up top. And we have one or more master database servers. Opcode caches. When talking about performance, you definitely have to look at opcode caches as well. Standard PHP looks something like this. Start your script, get the file off the disk, compile that file containing PHP tags into a set of opcodes, basically sort of the assembly language of PHP. Those opcodes then go to the executor executes them. If you have an include in your file, you go back up, you fetch the file off the disk, you compile it into a set of opcodes, execute the opcodes, function calls, you already have the opcodes for the function calls, you just go to the executor and execute those. That's sort of the flow in standard PHP without an opcode cache. When you inject an opcode cache into this, you check to see if the file that you're accessing has been cached already. If it hasn't, compile it to opcodes, store it in the opcode cache, execute them, and same thing. So basically you just have a cache check in between here to skip the compiling stage if we can. That can speed things up quite a bit. Depends a bit on what you're doing, how fast it will, or how much impact you'll see. If you're bottleneck, if you're I/O bound, for example, it's not going to help you at all. So if PHP and your CPU is fast enough to sit there and stream out data as fast as it can across your connection, if you're on a slow modem connection, for example, running a web server, an opcode cache isn't going to give you hardly anything because everything is going to be sitting there waiting for your I/O. If you are CPU bound, this can give you quite a bit. If you're CPU bound because MySQL is sitting there taking 10 seconds to chew on a query, then it's not going to help you much either. It'll speed up your parsing a little bit, but it's not going to do anything about the 10 seconds that MySQL is spending on your query. Then you have to go look at optimizing your query. There are a couple of different ones out there. APC, IonCube, Send, these are the main ones. There are a couple of others. There's BWware and others. Installation is pretty easy. Most of them are just a Send extension. All of them are just a Send extension. You put in PHP INI file, send extension path to a .so file. That's it. Restart PHP, and you now have an opcode cache working. Sometimes you have to specify whether it should be in shared memory or files and stuff. Sometimes you have to specify a path, but for most of them, there are defaults that will just work. All you have to do is download or compile an SO, put that in your PHP INI file, and poof, that's it. And it just works. So how much does it help? I did a little test with IonCube and the new APC 2 cache just on my laptop. It's a pretty crappy laptop, Pentium 3 700, 128 megs. This is a pretty meager server. Nobody would run a real web server on something this small. One thing that, well, my test file is a very short 6K. It outputs 6K of data, most of it HTML. It has 2 includes, defines 3 functions, loops a little bit, calls some functions. So there's a standard PHP stuff, although it's a little on the small side in terms of output. Most web pages are longer than 6K. This is an artificial benchmarking example. One thing you do have to realize when you're doing any sort of benchmarking and performance optimization of a big website is you have to look at your send buffer size. Your send buffer is your kernel level I/O buffer, if you will. So think of a page that's 100K long. So you connect to a web page, you get 100K back of HTML. This 100K was then sent to you by Apache, obviously, out through the kernel, out through the network card, down into your computer. If you have a fast connection, no problem. Say you're sitting in China, you have like 1 baud connection to this web server. It might take you 3 days to download that 100K. Now, does that mean that your HTTPD, that particular Apache process, is tied up for 2 days? What if 10,000 people in China all connect to your web server and download? Does that mean your web server is dead? Yeah, it does. That's bad news, except if your page fits in the send buffer. That's your savior here. The send buffer, basically, Apache hands off all the output to the kernel, and the kernel says, okay, I'll deliver this for you. If you don't blow your buffers, meaning you don't overwrite, if you go above the 65K default on Linux, then it's going to say, yes, I'll send this 65K for you, but that's all I'm going to send. So you're going to have to wait for the first 65K. Then you can send your last 35K or whatever you have left. So you have to just block and sit and wait for the first bit. So if you have an average of 100K pages, up your send buffer size. So that Chinese example, if there are 100K pages, up it to 128. K send buffer size, meg, I guess, okay, whatever you want. Depends if you like file serving stuff, you might have to go into the megabytes. Not sure how big you can go on Linux though. But still, the point is you want to get bigger than your normal page so that the kernel can take over delivering this stuff and your Apache will get freed up to service other requests. So even though you have 10,000 requests from China sitting there streaming in the background, your Apache server can still serve up fast requests to others at that point, if you have blown some other kernel limits, of course.